Hello, am I audible? Please confirm by tapping in the chat box if I'm audible. Great. So let's start this session. Let's wait for maybe 5 more minutes so that others can join and then we'll start this session. ठीक है, start. So, hi everyone. I hope my screen is visible to you all. So we can start the session. Um, please confirm once by tapping the chat box if I'm audible and whether my screen is visible to you all. So, it's on. So I am going to page, and today is 11th October 2024, and this is Friday. So this is the last session that we'll be having, and tomorrow is an extra session. That the link will be shared with you guys on the NPTEL Teams page itself, NPTEL page itself. So yeah, you can ask any questions related to any of the topics covered during the course of this semester in all of these tutorial sessions. Uh, either today or in the summary session that will be held tomorrow. Fine. So let's start. So which of the following is not a factor considered in Google's current search algorithms? So can anyone answer? Yeah, there will be revision in tomorrow's session. Okay. Uh, so yeah, in the Google's current search so in the earlier version of the page rank, the only important thing that was the only thing that was important was whether how much weightage does a particular page contains and how many incoming links are going to that particular page. If more heavy weightage pages link have a link to a given page, then its a page rank will be very high, and then it will be considered for a it will be that rank is known as page rank, and then a page having a larger page rank is more useful. But the problem was that let's say if there is some new page that has a better content and that has more relevant content, then it will not get higher ranks at the beginning. So page rank was actually biased towards the pages which are already existing in the network. So content relevance has been introduced, and then lastly, the user experience need to be important. So which of the following is not important? None of the above. All of them are is important. Option D. Okay, fine. So let's move on to the next question. In a weighted social network graph, what might be the edge weights represent? So can it represent the time of interaction between the users, the strength of a relationship, and the number of shared interests? Can anyone tell me what should be the correct answer? So yeah, so let's say we have a social network graph. Just this. So let's say we have a social network graph that looks something like that. So let's say these dots denote users, and the links between them shows whether the users shows any one of the properties between the users. Now let's say these links are weighted. Fine. So these edges are weighted. So let's say we give some weight to this edge W1, some edge weight to this edge W2, some weightage to edge weight 3, and so on. Fine. The question is, so this is what a weighted social network graph looks like. So let's say these nodes are the users. So this is user A, this is user B. So let's make it more familiar to you guys. So let's say this is user Ram, this user Shyam. Let's say this user is Sita, this user is Geeta, um, Mohan, let's call it Mohan, and let's call the other user Ram. So let's say these are the users in a social network graph, and the edges between them, there are edges between them. So the nodes represent the users and the edges represent some connection between them. So what can the weights on these edges represent? The question is this. So what can it represent? The first one thing is how close of a friends they are. So let's say for the Sita's edges, incoming edges, there are four edges that are incoming to Sita and outgoing from each. It's an undirected graph. Then let's say the weights are W1, W2, W3, and W4. And let's say I say W4 is maximum, is greater than maximum of W1, W2. and W3. Then it means that Sita is more close to really close friend to Rahul than others. So it can represent the extent of friendship between them, the strength of a relationship. Then the time of interaction between the users, it can represent the time of interactions. Let's say Sita interacted more with Rahul, so it interacted W4 seconds. Then Sita represented interacted with Shyam for W3 seconds and so on. Right. Then the number of shared interests. This is true because let's say Rahul and Sita love to play volleyball. They love to watch tennis. Maybe they love gardening. They both love painting. So they have four. Let's say W4 is there four. Now let's say Sita and Geeta do not like anything. Then W1 can be zero. Anything in common. So W1 can be zero. Let's say Sita and Ram like playing guitar. That is only thing that is common between them. Then W2 is one. Then Sita and Sham, similarly, Sita and Sham is singing, let's say. Then W3 is one also. So all of these. So Sita shares four in interests with Rahul, 1-0 with Geeta, one with each of the Ram and Sham. Right. So this way it can be used to represent the number of shared interests also. So the correct answer is option D, right? So let's move on to the next question. What is the purpose of a random walk in graph analysis? Anyone? So first of all, do you know the meaning of random walk? So can anyone tell me what is the meaning of a random walk? So let's say we have a graph that looks something like this. Fine. And let's say we are saying we want to do a random walk in this graph. Then what does this random walk mean? It's a very simple graph, as you can observe. It's not really dense, very small number of nodes. Then what is the meaning of a random walk? Random walk essentially means choose a node randomly and start and then choose a particular edge coming outward from that node. So edge going outward from that particular node. So let's say I choose this node and then I choose this edge, right? So, and then move across that edge to the node at which this edge goes. And then with some probability, choose another other edge of the other node. Now let's say this node has no other edges, so choose another node at random. So let's say I choose this node, and then with some probability you choose any one of the its edges. So let's say I choose this edge. So move along this edge and repeat the process with the other nodes and so on. So this is the meaning of random walk. Now let's say I have done this number random walk iterations for a large number of times. Then one thing that you can ensure is what would that be? Hello. So let's say I have done this random walk for a large number of iterations, and then one thing that I can be sure is after doing that as that many iterations, what I can identify is, can anyone tell me? So if you take a larger number of iterations using random walk, there is a higher probability that you will have covered all the nodes present in the graph until and unless your choices are biased. If your choices are completely random, then there is a high probability that you would traverse through all the vertices present in the graph. Fine. So what is the purpose of a random walk in graph analysis? To find the shortest path between two nodes? No, that's not true, because you need a systematic structured way to store the lengths number of hops between the nodes to identify find the shortest path. Moreover, if you are choosing some random strategy, then there is a possibility that you might miss one of the path that might be short or shorter than the shortest path that you are getting. Then to explore the entire graph and discover its properties, this is true, yeah, because option B, to explore the graph and discover its property. So this option is true because as we already saw, if you take a sufficient number of iterations, then you will eventually reach most of the nodes. Like in this graph, we have only 1, 2, 3, and 4. Four nodes are left that are not been traversed out of 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. So 4 by 11. So basically, you have traversed 7 by 11 nodes in this graph. So this is a very high probability in just 4 or 5 iterations. So yeah, so option B is correct. Then to prioritize nodes based on their degree, this is also not true because you might not reach to a node having a higher degree in the random selection process. To define the central node in graph, no, this is also not true. Fine. Anyone, do you have any doubts? Hello, am I audible? Great. So anyone, do you have any doubts related to this problem? Great. So let's move on to the next question. Which of the following are real world applications of directed graphs? What is a directed graph? Everyone, do you understand the concept of directed graphs? A graph can be classified into a directed or an undirected graph depending upon the uh, type of interactions shown by its edges. Fine. So let's say we have this graph and we have edges that are simply line segments joining the two nodes in this graph. Then this is an undirected graph. This is an example of undirected graph. Mm, fine. So for 1 minute, just. So let's say we have this graph, and this is undirected graph because the edges do not show any particular direction. Fine. Now let's see this graph, and let's see this edges. So this is a directed graph. Why it is directed graph? Because this graph says that if you are at node A, let's say, you can only go to node B from this graph, from this node via this edge, or you can come to node A from a node C via this edge. So these directions show that data can only, or information can be transferred from one node to other node in only one direction, depending upon the direction of the edge across that graph. Fine. So which of the following are real world applications? So social media friendship graph. So let's say we had uh where was this? So let's say we had this graph. This was kind of a social media graph. So we had this graph that represented that there are four friends. I mean, one, two, three, four, five, six. Six people represented as a graph, and each of these peoples are associated with other peoples using edges. Fine. So it is an example of social media friendship graph network. So basically, these edges suggest that two nodes that are connected via one of these edges are friends. Fine. So these edges, basically this edge between Geeta and Sita says that Geeta and Sita are friends. However, Sita and Mohan are not friends because there is no edge between them. Now let's say if I make it directed one, so let's say if I make this graph look like this. So what does this mean? So what does this mean? This means that Geeta is a friend of Sita and Sita is not a friend of Geeta. So that's not true. That's not how it works. If two people are friends, they basically both are friends of each other. So you can't use directed graphs to represent the social media friendship graph. Then family tree. So yeah, you can show a family tree using directed graphs. So uh, these are, let's say a person A, then there is a person B. They both have a child, or maybe they both have two children. Look that maybe one child only. That looks like this. That this person along with some other person C, these two have one another child. So this is a child D. So yeah, so A and B together they give birth to a child. So basically this goes like this. Then this goes like this. So you will need directed graphs here because you can't say that uh if it was undirected, that would mean that E came first than B. So basically, you can denote the time axis like this. So time is increasing like this, fine, in the towards the bottom direction, fine. So first A and B existed and they gave birth to E. Then E and C existed and they gave birth to D. So this order has to be maintained. Now let's say if it was undirected graph, then what would mean? It would mean that there is a possibility that E had some relation where it gave birth to A and B, and that was not possible. You can't give birth to your parents, right? So that's why it has to be a directed. There had to be one direction in which the time is flowing, fine, and that's why it can be used in family tree. Then linking of websites, that's also true. You can create you need a directed graph to show that websites are how websites are linked. So let's say I have a website A, then there is a website B, fine, and many more websites, right? So these are web pages. Let's call them web pages, fine. Now let's say A has a link that redirects user to the page B, fine. Now so let's say I denote this link using this graph that this page has a link that links to page B. Then there is a chance that and now let's say if I keep it undirected, then what does it mean? That it means that A has a link that redirects users to the page B. Similarly, page B has a link that redirects users to the page A. So if this was an indirected graph, but is that possible? Is it 100? Is it? Are you sure like this will happen every time? So there is a chance that some Wikipedia page refers to a research document documented at some website, but that website might not have a link to the Wikipedia page. Fine. So you need some direction. You need to show that page A has a link to the page B, but page B has no links to page A. Now there's a possibility that page B has three links, one each to pages C, then page D, and then finally page. And then let's say page E links to page D. So this is how a set of websites in the internet might look like. Fine. Now let's just C is having a link to B. Then also you need to denote it using an opposite edge going in the opposite direction. So yeah, you can use it your directed graphs to show linking of websites. Then airline route representation. So it's pretty simple. So let's say you are at NDLS, you are at Delhi airport, fine, and you are going to maybe let's say um, wherever you want to go. Let's say New York, fine. Then this is let's say your flight takes off from Delhi and reaches New York. Then you can't use an undirected edge to denote this link because the flight is going from Delhi to New York. It's not coming from New York to Delhi, so you have to use some directed graphs. Fine. So directed airline route representation can be used to show. Now let's say there was no edges, and then there was another flight that came from New York to Delhi. So there was no flight coming from New York to Delhi, but there were flights coming from Delhi to New York. Then how would you identify if this edge what this edge means? Then it will let's say if this edge means that there are flights from Delhi to New York and New York to Delhi back, but and actually there was no such flights return flights from New York to Delhi. Then what happened? Then it is not possible to use undirected graph edges, so you have to use some direction showing that there is no flight. There is a flight that allows you to go from New Delhi to New York, but there is no flight that allows you to come back. You might have to take a ship. Fine. So the correct answer is options B, C, and D. Fine. Anyone, do you have any doubts? Please type in the chat box. If you have any doubt or you feel or there are any technical glitches where I am not audible or my text is screen is not visible, then you should type in the chat box as soon as possible. Am I audible? Great. So I hope the answer is clear to you all. If you have any queries, please type in the chat box. So this next question requires your familiarity with the network X library. So everyone, are you familiar with the network X library? So let's do some programming. So let's install network X to pip. Oh, so network class is a library that allows you to create a graphs, directed graph. So you can see we are creating a directed graph. G equals to nx dot die graph. Then we can add edges using g dot add edge. Then you define the edge nodes. So nodes are A to B, and the weight of this graph is 3. This edge is 3, and so on. Fine. So this is how you use network X to define graphs. Fine. So I guess there is some issue with installation. Let me check. Hmm. Hmm. Okay, so there is some issue with the Python environment. So yeah, let's ignore it for now. So let's look at the code and then we'll be able to understand. That will be easier. Right. So what this let me recreate this graph for you guys and then you will be able to understand everything. Right. So this is a hmm, this is a network X library which allows you to create graphs in Python. Fine. So we are creating a graph G. So let's say we are initializing this graph G. That's this phrase represent a graph G. And this is a directed graph. Fine. So it's a directed graph. So it's a directed graph thing. Fine. So now first in the first line what we're doing, G dot add edge A and B and weight 3. So you have to create two nodes, node A, then node B, and the weight. It is a directed graph going from A to the B. So it will look like this. And then the weight is 3. Then again, you add edge between nodes A and node C, give a weightage of 2 to A to C, and the weightage is 2. Fine. Then B to D and weight of 5. So let's create a node D and give it a weight of 5. Then C to D and give a weight of so this is edge C, then this is node D, then C to D, and the weight is 1. Then from the node D to node E, so let's create another node E somewhere here and give a weight 4 here. Fine. So this is how this directed graph looks like. Then what does program say? It says display incoming edges from node D. This is a comment. Then incoming edges D is equals to G dot in edges D. And then we have to print the in edges to the node D. So how many edges are coming to the node D? Anyone? How many edges are directed towards the node D from its adjacent neighbors? Can anyone tell me? So yeah, you can see these are two edges. Um, one is acha, oh, hmm. So one of the edges is coming from C to D, and one of the edges is coming from B to D. Fine, fine. So these are the two edges that we are talking about right now. So this edge that points towards edge node T, then this edge that points towards node T. So there are only two such a. So what is the income number of incoming edges? Two. Fine. Anyone, do you have any doubts? Someone is answering three, but no, there are no three, only two edges are coming. So you might be confused that there is a D here also, but this says that D is source here for this edge. So this is a directed graph, first of all. So when you add an edge, it requires you to specify the source node, then the destination node, and then weightage to the node edge between them. So the here D is the destination for two edges in this graph. So there are total two incoming edges to the node D. So for further details, you can also check network X library. So you can this network X library. So when you look at this add edge, so you can see add edge function. It creates an edge. Fine. So let's move on to the next question. Anyone do have any queries? I guess no one has any queries. So let's move on to the next question. Which one of the following statements about page rank is true? It only considers the number of links, not their weights. It all web pages start with the same initial page rank score. And page rank is the only factor that determines the search engine rankings. Fine. Anyone, can you answer this? Option B. So that's false, that it only considers the number of links, not their weights. It considers the weightage. All web pages start with the same initial page rank score. This is true. Perfectly fine. Then page rank is the only factor that determines the search engine rankings. That's not true. Fine. So the correct answer is option B. Anyone do have any doubts? So I guess no one has any doubts. Fine. So just 1 minute. I need to plug in my laptop. Hmm. I guess no one. Any doubts? Let's move on to the next question. In a collage sequence, and if a starting value is a power of 2, how many iterations are needed to reach the cycle 4 to 1? So all of you are familiar with the collage sequence? Everyone? So the collage sequence looks like this. Sequence. So you are given a number, uh, a positive integer. Fine. Then these steps are followed for each iteration. You have to iterations until you reach 1. Fine. So what does it say? So two. The recorded video will be shared with you guys after the session. Right? So you have to repeat this iteration you until you reach 1. Repeat until. So let's say we have number n, sub number n. Let's say 100. Uh, repeat until n is not equals to 1. So what you have to do? If n modulo 2 is 0, so if n is even, and replace n by dividing it by 2. Else, if it is odd, then you have to replace n equals to 3 into n plus 1. So you will see that when you do follow these steps, ultimately you will or any positive integer for any positive integer, it will lead up to 1 after some number of iterations. The catch is there is no proof to this conjecture, so that's why it's called a conjecture. So if you do some experiments with the positive integers, you will found out that this is true, but there is no formal proof for this problem. Fine. So now let's say the starting value is a power of 2. So let's do some examples also. Let's say the input is 121042, something like this. Then the sequence will lead to just half is it is even. So what will be the half of this number? 5 to 1. Then this is odd. Just multiplied by 3. So what would be the that value? 3, 3 to the 6, 1563 plus 1. So 1564. Then again divide by 2. It would be 2714, 116, 2 to the 782. Then it is even, divide by 2. So 2, 3 or 6, 1, 8, 2, 9, 381. Then this is odd. Then multiply by 3 and add up 1. So it will be 3, 8, 3, 24, 4, 3, 9, 11, 4, 4. Then again divide by 2. You will get 2, 5, 10, 1, 4, 2, 7, or 2. 572 divided by 2, 2, 2, 4, 1, 7, 2, 8, just 16, 1, 2, 2, 6, 12. Find 286, then again divide by 2, 1, 4, 3. Then odd, you have to multiply by 3 and add 1, 3 3 are 9, 4 3 are 12, 3 1 are 3, 1 4, 429 plus 1, 430. Then again divided by 2, it would be 215. Multiply by 3 and add 1, 5 3 are 15. 3 3 4, 3 2 is 6, 6 4 to 6. Then divide by 2 to 323. Then again multiply by 3, add 1, 970. Then divide by 2. 2 4s are 8. 1 7 2 just 16. 485. And you repeat this, and you will see eventually that it will lead to 1. So it's getting very large for this number, but if you take very smaller numbers, then you can simply do this, or you can do some numerical computation and obtain these answers. Fine, whether it leads to 1 or not. Fine. So let's move on to the problem. And let's say now n is some value 2 raised to power x, something like this. Then in how many iterations we need the cycle, we will reach the cycle. So let's say we do some number of iterations and we want to reach to the cycle 4, then 2, then 1. How to reach to 1 through this cycle? So everyone, do you know what is the answer for this? That's really easy. So you know that it is a power of 2. N is a power of 2. So n divided by 2 will also be even. N divided by 2 in 2 squared will also be even. So in general, n divided by any power of 2, let's say L, will be even. And eventually you will reach 4, then 2, and then 1. Everyone, do you agree with this? So you simply divide by 2, divide n by 2 in each iteration, and you will again get an even number until 4, then 2, and then finally you will get 1. So in each iteration, by how many times the value of n is being reduced? Everyone, can you tell me? It is halved. Let's say if n was 512, then in the next iteration it will be 256. In the next it would be 128. In the next it would be 64. In the next it would be 16. 32. And in the next iteration it will be 16. Then in the next it would be 8. Then you will reach 4. Then you reach 2. And then you reach 1. Everyone, do you agree with this? If n is a power of 2, though, and every time you divide it by 2, it will lead to a number that is divisible by 2. And every time you divide it by 2, so when n is even and you want to find the collage sequence, what you have to do, you simply keep dividing a number by 2 until you reach 1. So let's see how many iterations it would take. So in the ith iteration, n would have become original n divided by 2 raised to power I. Now let's say I'm saying original n divided by 2 raised to the power I equals to 1. That means, what does this mean? That means that 2 raised to the power I is equals to original n. Fine. Then what should be the value of I? Then when you take log both sides, you get I equals to log of original n to the base 2. Everyone, do you agree with this? Hello, am I audible? Everyone, please pay attention to this logarithmic computation time so that we can reach to the answer for this problem. So everyone, do you agree with this? So let's say n was originally a power of 2. So you're not aware with this. So yeah, let's get back to the collage sequence. What does collage sequence says? You are given a positive integer, and what you have to do, you have to repeat this loop until n becomes 1. What does that loop says? If n is divisible by 2, divide n by 2. Else, if n is not divisible by 2, what you have to do? You have to multiply n by 3 and add 1 to it. And repeat this process until n becomes 1. So this is how you compute the collage sequence for a given positive integer value. And it is numerically it has been found that it will reach to 1, it will converge, the loop will exit for any positive integer value, but there is no formal proof. Now what this question says, if n is a power of 2, so n is 2 raised power x, let's say, then how many iteration it will require to reach 1? So let's see. Now let's say original one n was 2. In the ith iteration, let's say in the ith iteration, and the value of n becomes original, the original n divided by 2 raised power I, because in iteration n is divisible by 2 and we are dividing n by 2. The value of n will become original n, so initialized n divided by 2 raised power I. Now let's say I'm saying it takes I number of iterations to reach to the number 1. Then this means original n divided by 2 raised power I equals to 1. This means 2 raised power I is equals to original n. Now, when you take logarithm on both sides, you will get that the value of I is basically log of original n. Fine. So after log of n number of steps, number of iterations, you will reach 1 if n is a power of 2. So the question is, if the starting value is power of 2, how many iterations are needed? The number of iterations would be logarithmic in the size of starting value. Fine. Fine. Anyone, do you have any doubts? So we have seen that how it will require a logarithmic time to reach 1. Anyone, if you have any doubts, please type in the chat box. Everyone, please type in the chat box if you have any doubts. Fine. So let's move on to the next question. So for how many positive integers between 200 does the collage sequence does not reach 1? Can anyone answer this question? You have adequate amount of knowledge, information to answer this question. So for how many positive integers below 200 does the collage sequence does not reach 1? Anyone? Yeah, that's true. Because it's a conjecture, and you can for at least for 90 positive integers below 200, you can manually compute and find out that the collage sequence reaches 1 for each of the number positive integers between 1 to 0 to 100. Fine. So basically 1 to 100. So the correct answer is option A. Reaches 1 positive into yes 1 to 100. Fine. So let's move on to the next question. Which of the following statements is true about the collage conjecture? It has been proven to be true for all positive integers. False. It has not been proven to be true. It is known to be false for certain class of numbers. No. It remains an open problem and its status in unknown. That's true. And it only applies to prime numbers. That's also false. So the correct answer is answer C. It is an open problem. Fine. Everyone, do you have any doubts? Great. So let's move on to the next question. Find the number of sequences required for the collage conjecture when applied to 5 to reach 1. So let's solve this here itself. So we are given a number n equals to 5. Fine, and you have to apply collage conjecture. So 5 modulo 3 modulo 2 is equals to 1. So it's not 0. So what you have to do? You have to update n equals to 5 into 3 plus 1, which is 5 15 plus 1 16. Now n check n modulo 2, which is 0. So you update n equals to 16 divided by 2, which is 8. Then again 8 is divisible by 2. So divide by 2, which is 4. Then again 4 by 2, which is 2. Then 2 by 2, which is 1. So how many steps? 1, 2, 3, 4. 4 steps here and 1 step here. So total 5 steps. So someone is asking in exam which type of questions will come. So that I am not aware of because I am not hosting the examination. So you can contact that NPTEL team. So everyone, did you get the answer? How many total 5 steps are required? You can also solve this simply by looking at this. So after first step, the value of n is 16, which is a power of 2. And we know for a power of 2, how many steps are required? Logarithmic. So log of 16 raised to power 2 is anyone? It is 4. 4 plus 1, which is 5. This is how you will reach the answer without manually doing the computing the number of steps. Fine. Anyone, do you have any doubts? If you have any doubts, please type in the chat box. Y plus 1. Okay, fine. So initially the value of n was 5. So 5 is not divisible by 2. So what you do? You multiply 5 with 3 and add 1 to reach 16. Fine. So how many steps are required to reach the number 16 from 5 to 16? 1 step. So let us see. Fine. Of steps to reach 16 from 5, we require 1 step. Now, number of steps required to reach 1 from 16. How many? Log of 16 to the base 2. So I'm not writing base 2 right here. Just assume that the base is 2. What is this value? 4. Fine. So total number of steps, 4 plus 1, 5. Thus, the number of steps required to converge. How many? 1 plus 4, which is equals to 5. Fine. Vikram, is this clear? Fine. Anyone, do you have any doubts related to any problem in this tutorial session or even earlier tutorial sessions also? If you have any doubts, just type in the chat box. Great. So, everyone, let's take a break for 10 minutes and then resume. So, yeah. So, no one has any doubts. So, let's take a break for 10 minutes and then let's take a break for 5 minutes and then we'll resume at 7:20. Till then, please type in the chat box if you have any doubts, and we will solve some programming problems after the break. Fine. 20. Hi everyone, welcome back. Let's resume. So as we saw in the earlier problem, that there is a sequence, collage sequence that you can compute for positive integers. Um, it returns, it will converge, and it will result in making any positive integer to one if you follow the steps. So let's check that if it is true for first 200 positive integers. So let's create a function. Check convergence, check collage convergence, and let's take an integer n, and then let's run a loop for I. No, okay, huh. While n is not equals to 1, what you have to do? If n modulo 2 equals to 0 and divide equals to 2, else n equals to n into 3 plus 1. Fine. So this you have to do. And then, yeah, that's it. If the loop exits, then you have to return true. Let's define some maximum number of iterations. So let's define it to be 10 is a very large number. Fine. And then update max pairs plus equals to 1. If, and let's do, so this is a halting problem. You don't know if it will exit or not. If max iter is greater than, yeah, let's define iterations. Iters equals to 0. If iters greater than equals to max iters. So if maximum number of iterations are already done and still it has not converged, then this means it will not converge. Fine. Fine. So this is the check collage function here. From collage code, check collage. Fine. So let's check it. Check collage sense for the number 1. So it returns true. For number 2, it's true. For number, let's say 5, it is true. Let's make the number big. Let's 200. It is true. Fine. So now let's check for all the numbers between 1 to 100. So let's define some Boolean flag f equals to false. Now for I in range 200. So for all the positive numbers until 200, so 1 to 201, what you have to do? If check convergence, check collage convergence of I, if this is true, so let me check if, okay, what you have to do? You have to break, not break, you have to return false basically. Fine. Fine. So let's again import from collage. Fine. Now for, let's declare our flag to be false. Then for I in range 1 to 200, what you have to do? If check collage chance of I is false, what you have to do? You have to set f to be true. This means we have found a number between 1 to 201, an integer that does not converge using this iteration. Now let's check f. F is false, so f never gets true. This means we were unable to find any number, positive integer between 1 to 200 that does not converge using collage steps. Fine. Everyone, do you have any doubts? Please type in the chat box if you have any doubts. Hi guys, let's resume for a few moments. I have an urgent call. So yeah, apologies for that. No, collage is not a library. I have created a function check collage convergence in the file named collage here, and then I am importing in my terminal here. So you can do this simply whenever you want in the IPython kernel. So if you have a file named let's say collage.py here, then in the file if you have a function check collage convergence, then you can import it like this. Fine. So you are not, if you are not able to import, then there is a possibility that you have opened the Python the spider ID in a separate folder. So you have to make sure that the file collage.py and um, the folder in which you are doing this. So can you just type ls here? You have to ensure that the file has to be in the same folder. in which you have opened your Python IDE basically. So when you type ls, you can see I have a file named colas.py here. That's why I'm able to import everything from that file. Just type ls, then let's see. Just type ls and see if the file is being present there or not. So is there a file named collage conjecture, and in that file there is a function called check num. Just type ls in the to see if you are in the correct folder or not. So when you type ls, it will list all the files present in your present working directory, and then you can check if it is there or not. Fine. So yeah, these were. Let's move on to some more problems. Hmm. So let's do some programming problems. Fine. So let's take up this problem. Hmm. So where's the speaker? So we have this problem. So we are given a square metal plate in 2D, and the spatial extent of the metal plate is given by the spatial extent is given by x is greater than equals to 0 and less than equals to 5, y is greater than equals to 0, less than equals to 5. Fine. Someone is saying screen is frozen. Is this true? So I believe it should be visible. Fine, fine. So let's look at this problem. So we are given a square metal plate in the XY plane. So let's first define the XY plane. Okay. So this is the X plane. This is the Y plane. Okay. X axis and Y axis. And then define a plane whose extents are given by 0 to 5. So this is the origin and this is the value 5 on the X axis. Similarly, this is the value 5 on the y-axis. The plate is defined as such that x is ranging from 0 to 5. So the values that are acceptable to be on that plane is that the value x value should be between this range. So all the values in this region are acceptable. Fine. Now the another constraint is the y value should be less than equals to 5, greater than equals to 0. Then all the points in this region. So when you check the overlap between these two regions, only this region is allowed. So this region is specified our plane. So let's define, plot that region. Okay. So we have this region, and this is a square metal plate placed on the XY plane. Then the temperature at any point x comma y is given by the following equation. The temperature is measured in Celsius and can be negative also. Fine. So this is the equation. So your for any point x comma y lying on the plane, that there is a function that can be used to compute temperature. So when you apply some temperature function here, you get some temperature in degrees Celsius. Fine. Then a microorganism lives on the surface of the metal plate. So microorganism basically lives in this region. Fine. And this plate has been heated up, or it has been defined some temperature depending on the locations on the plate. Then the organism cannot survive in high temperatures and instinctively moves to the regions of low temperature that are less than or equal to some given threshold. Then what our program has to do, we are given some location for the we are given some threshold temperature, and fine. And so basically we are given some threshold T, and we are given some temperature function over this plate, and the organism has to lie on this plate. And you have to check if there is any region present on the plate where the temperature is less than this temperature T. If that temperature T is less than this threshold T, then if there is only even a single point where this temperature exists, then the organism will live, otherwise it will die. Fine. So we have to identify if the organism can live on this plate or not. And also the organism can only live on the locations in this plane where the coordinates are integers. It cannot live on fractional coordinates. So let's say this was the XY plane and this was our plate. So it can live only on this 1, 2, 3, 4, 5. So the organism can live only at integer nodes, integer coordinates. Fine. So these are 1, 2, 3, 4, 5. These are the coordinates, and the organism can only live onto these coordinates. So the organisms can live here in the pink dots basically. So when you look at these pink dots, the organism can live at these dots and no place else. So these are basically dots are the integer coordinates on the plate. Fine. So how to identify, given a threshold t, how to identify if there is a dot where the organism can live? What we can do, we can simply iterate through all these locations, all these dots, and check the temperatures at these dots. And if there is even a single dot where the temperature is less than threshold, so let's say the temperature is our the or temperature at dot t dot is less than the threshold, then the organism will live, otherwise it will die. Fine. So let's proceed with the program. So let's call it organism. Fine. So, fine. So let's call the function def lives. Fine. And you are given a threshold. Then you have to check if the organism lives. So let's define another function. Uh, so what we have to do, you have to simply iterate through all the dots in the plane for I in range 6. So 0, 1, 2, 3, 4, 5 for j in range 6, 0, 1, 2, 3, 4, 5. Temperature is temp equals to temperature at I comma j. Now if temp is less than t, return true. So basically organism lives, else what you have to do, return false. Fine. So now let's declare this temperature function. Temperature function, it takes two values x comma y, and it returns the value of temperature, which is given by 30 plus x square plus y square minus 3x minus 4y. So it is 30 plus x squared plus y squared minus 3x minus 4y minus 3x minus 4y. Fine. And if this is true, then the organism lives. So let's import our function. From organism import lives. Now let's check if our threshold is 10, the organism cannot live on any place on the metal plate. So now let's make it 100 degrees. Then yeah, there is a point where organism can live. Now let's say what about 11? No. So let's check at which temperature, what is the least temperature at which the organism will live. Oh yeah, there is minus 4y. Yeah, there was a bug in our program. Fine. So let's check the temperature where the organism lives. So t equals to, let's say 0, range 100. Let's check if the organism lives somewhere. If lives at I, what you have to do? T equals to I and then bracket. Fine. Let's see. So 25 degrees Celsius. 25 degrees Celsius is the minimum temperature. It is the threshold temperature at which the organism will live on the plate. Fine. Anyone? Do you have any doubts? Please type in the chat box. So anyone, do you have any doubts? Please type in the chat box. So first thing, someone is saying why need not to consider. What you need not to consider? I am not getting a problem. Then someone is saying what is the purpose of equation in the equation question. So basically this equation tells you that what is the temperature at a particular dot in this plate. So these are the plates, and this equation tells you that what is the temperature at particular plate. Fine. Fine. Why is J basically? Yeah. Then someone is saying for T value, T is the threshold that is being given by the user. This is an user input. So someone is saying that why J is not considered. So here, okay, let me recorrect this. So let's take threshold value to be 0. For threshold in range 100. This is a separate program. Please don't confuse between the lives function and the threshold being passed to that function. Then threshold equals to T. That's it. Fine. So J is being considered in the lives function. So they are completely different piece of code. So that's why you are getting confused. Oh yeah, I haven't break it. That's why it's giving the final value. So you have to break it. Fine. So now when you check threshold, it will be 25. So I missed the break statement here in the loop. Any other doubts? So basically the t variable is being passed as a threshold to the lives function. So when you look at this lives function basically, it takes in a threshold t, then it is iterating through the grid using the variables I and j, computing the temperature using the variables I and j, checking if the temperature at I and j is less than the threshold. If that's true, then return true. If we find no such point in the plane, then return false. You are confusing the variables at different places. So anyone, do you have any other doubts, or we can end this session? If you have no doubts, please, you can leave the session. If you have any doubts, please type in the chat box. So I don't know, you can look at the NPTEL page and then get content from there for the examination. So there is an extra session tomorrow from 2 to 4. So yeah, I'll be covering all the topics that I have covered throughout the semester, throughout this semester. Yes, all the recordings are shared with you guys.